So today I'm going to talk to you about 4 years and counting of the Trees Around the Globe Student Research Campaign. And once again, as Giuseppe mentioned, my name is Brian Campbell. I'm a NASA Senior Earth Science Specialist and the Globe Observer Tree Science Lead based out of the NASA Wallops Flight Facility in Virginia in the United States. So we're going to talk a little bit about trees because this is a campaign, as it says in the title, that we've been running for 4 years, just over 4 years. We just started our 5th year on 1 October of this year. And we have participants from all over the globe who are part of this. I'm the lead for this campaign, and I wanted to showcase a couple things with you and how we tie the NASA Earth observing missions that I work with to the GLOBE program, which is a NASA-funded program with support from NOAA, the National Science Foundation, and the U.S. State Department. So the Trees Around the Globe Student Research Campaign is a campaign that we started on the 15th of September in 2018. And that aligned to the launch of the NASA Ice Cloud and Land Elevation Satellite 2, or ICESat-2 satellite, which can measure the heights of trees from space, okay? Right now, we're in year 5. This year 5 runs until 30 September 2023, and we are looking at change over time and organizing student research. And we focus this classroom and outdoor research with students from, it can be elementary school, primary school to secondary school. Even, we've had some college students present as well. But what the deal is here is that we have students measure tree heights, look at land cover, and greenings, green up and green down, the greening up of the springtime and then the green down of the fall and winter. And then also the carbon cycle. And students take data, they analyze the data, and they create student research projects based on their local environment, but also can use data from other places around the world that students and educators may have submitted to the GLOBE program. All right. So here is our campaign team. We're spread out, throughout the United States. I'm the lead based in Virginia. We have my colleague, Peter Nelson, who is at Oregon State University. He is a associate professor there. We have Peter Falcon. He's at the NASA Jet Propulsion Laboratory in Pasadena, California. And then we have 2 other colleagues who work part-time on the program, on the campaign. Dorian Janney out of the NASA Goddard Space Flight Center, and Dr. Christopher Schumann, who is essentially a cryospheric, he's a glaciologist, but he is a campaign subject matter expert. So let me show you this quick little video here. Hopefully you get the sound okay. But there's no talking. It's just a promo into what this actual campaign is. So one of the major goals here with this campaign is that we want to be able to compare. We want students and teachers and even citizen scientists to be able to compare the data that they get when they measure tree height observations or they measure land cover observations. Compare that to the NASA satellite and instrument data, because having that really robust data set allows students and professional researchers around the world. It affords them a larger database to pull data from. The GLOBE program has over 250 million observations of 50 different measurement protocols, everywhere from air temperature to mosquito habitats to soil temperature, soil characterization, looking at water chemistry like alkalinity, pH, all these things. But with this campaign, we have different collaborations with a lot of different campaigns with the GLOBE program, including the European Phenology campaign, which some of you may be part of. And anybody can join these campaigns, especially the trees around the globe. You know, it's focusing on students and educators, but we do have citizen scientists and just casual scientific observers who come to our webinars every year, basically every month. So a little bit about the last 4 years is that we've had lots of participation. These are presentations that we've had at webinars from countries all over the world, from Croatia to Malta to Saudi Arabia to Taiwan Partnership to Thailand, to Estonia and the United States, of course. So we have folks coming in from, and this, when I say folks, we have scientists, researchers, students, educators from all over the globe interacting with each other to help us understand the importance of tree height and land cover with our changing climate. And this is the big thing about NASA. NASA really looks at change over time. And this is what we've been doing every year. We've been looking at the data that students have been bringing in every year during the campaign and seeing, and the students can figure out where they can grab this data to help them understand their local environment better, but then have other people be able to understand the global context of all this data coming in. We had the spring 2022 tree height and land cover intensive observation period for this campaign, where we had over 2,500 tree height observations coming in from over 24 globe countries, and we have over 400 land cover observations coming in from 16 globe countries. So this is one of the first things we did in year 4 to get this out here, to get as many observations as we can in a short amount of time. So I like to show this graphic, even though there's a lot on here, but why we study tree height. Tree height is the most widely used indicator of an ecosystem's ability to grow trees. Think of it this way. Think of two parts of the planet. Think of the Amazon rainforest and the Sahara Desert. One of these is very conducive to growing trees, lots of tall trees. That would be the Amazon rainforest, because we have the right dynamics here. We have the right variables. We have a very rich organic soil. We have the right temperatures. We have the humid climate with the right amount of precipitation. Conversely, the Sahara Desert, we have sandy soil, not nutrient-rich soil, shallow roots, not a great place to grow trees in that hot, dry, arid climate. So where we see lots of tall trees, we know we have a healthy ecosystem that has the ability to continue to grow trees, and that's what we're trying to protect over time. Tree height also allows you to track the growth of trees over time and help us understand the gain or loss of biomass, basically the amount of organic material in a particular area. But this helps scientists, these simple tree height observations help scientists understand how much carbon is being pulled out of the atmosphere by trees and forests around the world based upon their height and also their circumference. Okay, so scientists are looking all over the planet to create these global maps of where the trees are and estimating how much carbon dioxide is pulled in from the atmosphere by these trees and sequestered or stored by the trees in their, when they grow in their trunks, branches, leaves, roots, all these things. So NASA has several missions in space right now, including the ICESat-2 mission that I mentioned earlier. But then we also have a mission, an instrument called JEDI, the Global Ecosystems Dynamic Investigation on the International Space Station. So we have these in space because there are over 3 trillion trees on the planet and approximately 78,000 tree species. So we combine the space-based data with the ground-based data, and this through the GLOBE program, which also stands for Global Learning and Observations to Benefit the Environment. And it was a program started in 1994 and has been continuing, currently, and we have participants from 127 countries with a huge contingent in the Europe and Eurasia region. But here with the GLOBE program, historically, we had students go out and take tree heights, building a handheld clinometer, an instrument used to measure slope and angles. But we also designed the NASA Globe Observer Trees tool for citizen science, where you can take tree height with your mobile device, okay? This is just showing you the handheld clinometer for tree height. Pretty simple to do, and we have a little step-by-step how you figure that tree height out. But not every school has the time to build clinometers and go out, so we actually have it set up where we program the mathematics into your phone, where you use the phone's camera and built-in magnetometer to be able to measure the height of trees. And it usually takes, once you get used to it, about a minute or so to actually take a tree height measurement. That happened to be my son a couple of years ago, showing just how easy it is. But this ties together what I've been mentioning, where we combine the ground-based data that you see here through the app with the NASA satellite data. And we have a quick video, about 50 seconds, showcasing this and basically how to use the app and then why it ties into NASA. So with all these observations, literally, you know, a terabyte of information coming in a day from the NASA satellites and instruments, with the ground-based data of tree height, we're really creating a really robust data set for student and professional researchers alike. Now, what's cool about this is that, you know, we have it set up that if you go out and take a tree height observation and you happen to have a tape measure, or like a tape measure, an expandable one with you, you can actually measure the tree circumference, which will add another variable to this observations. But, you know, we have a couple of rules here, but you can go on the website and check this out, learn all about it. And it's a free app, and all you do is sign up with your email, and that's all you have to do. You don't have to give us any other information. You can just go in and search for the NASA Globe Observer and download it, send your email, and you'll get a message back saying you're ready to take observations. And right now we have several different protocols. But with this campaign, because it's 4 years of the campaign, we utilize observations coming in from the satellites, from the NASA Globe Observer Trees tool, and from students and teachers using the handheld clinometer. And we tie that into the land cover data that we take, because we also have a land cover tool on the Globe Observer. But then we also have land cover data from NASA and the United States Geological Survey, USGS, and the Landsat series of satellites, which have been in space, consecutively for about 50 years now. So here we have some maps. We have a map of the United States and one of a global map showing all the different tree height observations that have come in from the GLOBE program, potentially as part of our campaign. I say potentially because not all these these observations that have come in come from campaign participants. And I should mention that the campaign is active right now in 60 countries. We have 60 participants coming in to the webinars from approximately 60 countries every month. So we have a lot of participation. Even though the GLOBE program has 127 countries, not all of them are part of the Trees campaign, but we have just about half of all those countries who are active participants. So we have over 73,000 tree height observations from almost 24,000 global locations right now in the database. So scientists can use your data. There's a lot going on in this image, and I won't go through all of it, but this is showing you how I, as a specialist and scientist at NASA, can compare the NASA Globe Observer tree height data with the NASA ISAT-2 data. And it's just showing you how you match up the photons and how you figure out how close the tree heights are between what you observed on the ground and what the satellite measured from space. We just finished the NASA Globe Trees Challenge 2022, Trees in a Changing Climate. And it was a month long. It was month long, and it lasted from the 11th of October to the 11th of November. And this graphic that I have here shows you all the countries that participated in this. There were approximately, I think it was 54 countries that were part of this who took observations during this challenge. And what we wanted to do is we wanted to do what's called data density. We wanted to get as much data as we can in particular areas for a short amount of time. So this is my last slide here. There's a lot here. You can go check this out. My contact is on the bottom if you want more about this. All these links here go from the GLOBE program to the TREES campaign, which I talked about today, how to get to the GLOBE Observer, looking at the TREES challenge, looking at the land cover tool, how you compare the data on what's called a site called Open Altimetry, and a little bit about the ISAT-2 mission. So I will stop sharing and come back to the main room. So thank you, Giuseppe, and everyone else.
Thank you. Thank you, Brian. Very, very interesting. So perhaps we can go through a few questions if you're ready.
Sure.
So, for example, what were the main challenges in this project that you developed, Brian?
So some of the main challenges are, one is doing comparisons between the ISAT-2 data and the TREEI data, because we really focus on, if you are going to go outside and take tree height measurements, you can also go onto the Open Altimetry online tool to find out if ISAT-2 or even JEDI has measured the tree heights in your area. And sometimes the satellite is flying overhead, but there were no tree height observations. And that could be for different instances. That could be maybe the satellite was in safe mode and it wasn't firing a laser, or most likely it had to do with heavy cloud cover, because the ISAT-2 mission fires 10,000 laser pulses per second, and the JEDI mission is about 246 laser pulses per second. And if there is really intense cloud cover, or even like cirrus clouds made of ice crystals, we get a lot of refraction. So the really thick clouds, the lasers cannot penetrate through those clouds and get down to the earth, to where those trees are. So they just kind of get absorbed or scattered in the clouds. So that's one of the tricky things. Another one is to find, for teachers to find time in their curriculum around the world to take the kids out, the students out, and take observations, and then coming in and doing analysis. But I also think one of the major issues is when we have these live webinars, finding a time that is good for everyone around the world, which is impossible, because I'm coming in from the US, my colleagues on the mission, also on the campaign, are from the western part of the United States, so they're 3 hours earlier. But then we have folks in like Thailand and Taiwan who want to become part of it, and they're 12 hours ahead of us. So it's really tricky to find. That's why we record everything. We have had 51 webinars for the campaign so far. So, but we have recordings where thousands of people watch these recordings after they're posted on our website. But yeah, there's always, and it's always hard to predict the issues that pop up. You know, for instance, like JEDI, they're talking about they're going to, disassemble the JEDI instrument on the International Space Station at some point in the near future, but we don't know when. So that data won't be available after a certain time. And we don't really know that time when it may be, discontinued. ISAT-2 is still up there for as long as possible. ISAT-2 is the independent satellite, so that's still up there. That's been up there since 2018, and we hope that we get another at least like 10 years out of it.